In this video, I'm going to be talking about vectors. Vectors are a very powerful concept in C++. Vectors are container classes, and they're actually containers for objects of the same type. So they can contain a collection of objects. So as usual, you start off by including the vector header file. And vectors are part of the standard namespace, the standard library. So if you want to make your job easier when it comes to typing code, you can actually use this using declaration std vector. All right, there are different ways in which you can initialize vectors. So let's start by doing looking at how the first what the first way is. So I have declared a vector my v1, and I'm specifying that I need it to be allocated 5 memory slots. So the vector is actually the vector class is a template class. So I need to specify when I'm instantiating a vector, I need to tell what type of objects I'm going to be storing in the vector. And so in this case, I have integers stored in the vector. So I have requested 5 spaces. I've requested memory for 5 integers. So that's what my first vector, my v1, is going to be like. And now the vector class also provides functions using which you can inspect the size of the vector. So there's a size function, and there's also the empty function which checks to see whether the vector is empty. Now let's quickly run this bit of code. Let me set a breakpoint here and let me run this code. So as you can see here, the size of MV1, my V1 is 5. It's what's expected because I've allocated space for 5. It's definitely not empty. So even though I may not have explicitly set up integers and stored integers in this vector, by default, when you use an integer, so an integer is a built-in type, integers are default initialized to a value of 0. So let me quickly inspect this vector. And as you can see, there are 5 integers which have been stored, and each of these integers have been set to the value 0. So let's keep moving down. Yet another way to initialize a vector is to actually specify the size and then what the initial value of each of these elements could be. So that's what is done here when I say my v2, and I'm specifying 10 and 2 here. And as usual, I've written a loop to output these values to the console. How do I output? I can use something called indexing. So I'm able to index into each and every location in the vector. Something similar to the array syntax that you may have used in other programming languages. The only thing that you need to be careful about here is that you do not overshoot the vector and try to access a location which might be outside the bounds of the vector that you have allocated. So let's quickly run this bit of code as well. So as you can see, the values of my v2 are, and you have 10 twos there, and that's what we expect. So if we take a look at inspect it, yes, so that's what has happened, and that's what we expected. Let's keep moving on. The other way to initialize a vector is to use something called an initializer lister. So as you can see, I have braces here, and I have written out 5 integers. So this vector is going to store 5 integers: 29, 32, 55, 35, and 24. And thereafter, what I'm doing is I've written a little bit of code here to modify the values in that vector. And each of these values is actually being captured by reference. So I'm modifying the original values of the vector. So my v3, after this modification, as you can see, I'm multiplying each value by 2. I'm using the compound multiplication operator here, and each value is going to be updated to its value multiplied by 2. So finally, I output the modified values. So let's see how that works. Let me quickly move further down. So as you can see, the modified values are 58, 64, 110, 70, and 48. That's what we expected. So that's yet another way to initialize a vector. All right, now if you notice, I have been explicitly specifying the size of the vector, or I've been initializing to elements that I already know about. What happens when I do not know the size of the vector and I do not know what elements I'm going to be storing in the vector? So that's where the power of a vector comes in. And the vector class provides a function called pushback. Now, when you use pushback on a vector, you are actually appending to the vector. You're actually storing an element at runtime. Whatever that you may capture at runtime, you can actually store it in the vector. You push it to the back of the vector. So you don't have to explicitly specify the size of the vector. You don't have to allocate memory for it beforehand. So all that I've done here is I've just defined an empty vector. So vector myv4. It's not been allocated a size as yet, and neither has it been initialized to any values. So all that I do is I've written a loop here which reads from the console, and as and when I get a value from the console, I'm pushing it into the vector. And to do that, I'm using the pushback function. So this is usually the recommended way to populate a vector, because vectors perform well when you do not explicitly request memory and you don't really allocate memory for a vector. So all this happens internally. Vectors are able to reallocate as and when required, depending on how your program runs. Vectors can reallocate. They can actually uh, ensure that your vector is always available, but there is some reallocation of memory which happens behind the scenes as and when your vector grows. So that's the bit of code that you see here. Remember to use pushback when you are trying to capture values at runtime and you have no idea of what the size the vector could be like. And let's move further down. So there's also this concept of iterators. Every container class in C++, not just vectors. So, you could have queues, could have priority queues. All these container classes, they have a mechanism called iterators. So an iterator is something similar to a pointer. You can use it to point to an element in the vector, and you can dereference it. You can dereference the iterator. An iterator is just used to move over each and every element in a container. So in this case, I'm declaring an iterator, VIT. So since this vector is a non-constant vector, I'm using an iterator, just a regular iterator. Suppose I had, a constant vector which cannot be modified, then I would use something like a constant iterator, something similar to having pointers to constant values. In this case, I'm not having any, it's not a constant vector, it's just a regular vector. So I am declaring a regular iterator to capture the values and point to the values. So how do I start iterating? Once again, there is a function called begin, which is provided to point to the first element in the vector. Similarly, the end of the vector is um, pointed to using the end function. So in fact, end actually points to one element beyond the last element in the vector, points beyond the end of the vector. So that's how I get my iterator. So I start by pointing to the first element using the begin function, and then I keep iterating over the vector. So I just keep incrementing the iterator, something similar to pointers. And just like how I said, you can dereference the iterator to get you the value of the iterator. So if you want to be very specific about what type of iterator you using, you can go with this syntax, or C++ always makes it easy for you by using the auto keyword. You don't have to really specify the type of the iterator. So all that I do here is I've replaced the type of the iterator with the auto keyword, and everything else remains the same. I just iterate over the vector and then I output the values. So that's what is done here. So as you can see, you have this bit of code where I enter values from the console, I push it into the vector, and then I have two ways in which I'm sending the output to the console. Both these loops are doing pretty much the same thing. So this the second loop has just been created to demonstrate how you can use auto. So let's actually do that. Let's run this bit of code and then see what happens. have the prompt here which asks me to enter the values. So let me enter some values: 89, 123, 78, and let me terminate that. All right, so as you can see, the values entered are 67, 89, 123, 78, and the same thing is repeated in the next line as well. So that's what we expected. So that's it, folks. It's a quick introduction to vectors. A vector is a very versatile data structure which you can use. So be sure to use it, and let me know if you have any questions. Thank you.